Alrighty. The audio should be fully functional now. Sorry about that, folks. Send out a remind. I'll just wait another moment. Get you guys back. Folks are asking about how to access the live stream when Schoology is down. That's why I'm using YouTube. I anticipated this was going to happen. Is audio good now? Question mark. Someone's saying YouTube is down. That does not make a whole lot of sense. Sweet. Wonderful, thank you. I guess a couple of people are having trouble finding the stream since they've been going through Schoology to get here, and Schoology is down. Hooray for the downness of Schoology. There's people watching now. All right, well, I'm going to go ahead and restart the machine, maybe? I don't know. All right, guys, let's thank you for your patience with all that. Let's take a look at what we already talked about a bit here. So in behavior, basically all you're looking for is the function positive or is it negative. Okay? The real roots, right? That's the rational and irrational ones. Anything that is not imaginary. let's see, multiplicity. How many times does that 0 or root occur? That's it. Everything else is what we've been doing. So, like I wrote before, the two parts of the polynomial function that affect in behavior, that's going to be the degree of the function and the sign of the leading coefficient. Not Schoology. YouTube. Anyway, so I looked at the leading coefficient. No, I haven't done that yet. Looking at the exponents for each of the first terms, they're in standard form. And this is 2. 2 is an even number. That's 5. It's an odd number. There's 3. It's an odd number. And 4 is an even number. Okay. Down below here, these are all examples of even functions. Okay. Specifically, these are these very even functions here. So negative x squared plus 2x, that's this. That's what that graph looks like. Here's x to the 5th minus all that stuff. That's what the graph looks like. This one is not that graph. I don't know why I would have... No, this doesn't make any sense. Scratch everything I just said. These are not those graphs. I don't know what they are exactly. But they're all even. Okay? All even functions have this end behavior. They're either both pointing up and up or down and down. Okay? End behavior is either both up or both down. Okay? If the leading coefficient of the even function is positive, then both left and right sides point up. One moment. Yes, I know Schoology is down. I am on YouTube right now. If it's negative, both the left and right arrows, they're going to both point down. Alrighty? So go back to the sample functions and just identify if the leading coefficient is positive or negative. Yeah, that's why I kind of thought this might have been the case. But yeah, here, this is a negative leading coefficient because they're both pointing down. This one would be a positive leading coefficient, whatever it is, because they're both pointing up. This one is also positive because the arrows, the left and right arrow, are both pointing up. And this one has a negative leading coefficient since both the left and right arrows are pointing down. Okay? So that's even. Odd functions. That's what your odd functions look like. All odd functions have this end behavior. So you're either looking at left, down, right, up. So kind of going like that. And that is your positive. Or it's kind of going like that. That is your negative. If the leading coefficient is positive, right side is up, left side is down. If the leading coefficient is negative, right side points down, and left side points up. If you want a helpful way of remembering this one, I think even is going to be not too bad. I mean, positive is up, negative is down. Not a whole lot of trickiness behind that. Here, for the odds, think about the number 1. 1 is an odd number. So something like y equals, and I'll just make something up, 2x plus 5, okay, it would have a positive slope. Okay, positive slope. all of the functions, the odd functions that have a positive leading coefficient, would be similar to a positively sloped line. Similarly, y equals negative 2x plus 5. That's a negative slope. And a negatively sloped line basically goes something like this every single time. So take a look. Here the arrow is pointing up this way and down this way. This is a vaguely similar to a negatively sloped line. So this is a negative leading coefficient. This one has the same basic shape where the arrows are. So it's a negative leading coefficient. And then both of these are positive functions. Both have a positive leading coefficient. Alrighty? I'll pause for a second. Okay, this one here, number 12, you're going to reference this all the time. If we were in regular class type situations, when a test would come or something like that, I would recommend to you that the very first thing you do when you get your paper is to draw this Punnett square. All right, an even positive function basically has that shape. It's poorly drawn, but you get the idea. Both arrows are pointing up. If it's even and negative, then both of them point down. Okay, the odd ones, positive, that goes like this, and negative goes like this. That's it. That's all you need to remember about end behavior. There are going to be some like symbols that you'll have to worry about later, but for now, well, that's basically it. When it comes to putting the graph on paper, that's all you need to do. Here we go. For each of the following graphs, state if the function shown is even or odd, and then tell if the leading coefficient is positive or negative. Tell you what, I know you were kind of live here, but I'm going to just give you guys a moment to look at these 8. Okay, you can reference the Punnett square that we just drew. Let me bring that back up on the screen. Okay, there's our Punnett square. Please identify if each of these are even or odd just by looking at the graph, and identify if they are positive or negative, again, just by looking at the graph. Okay, take a moment to do that right now, please. I'll give you just a couple of moments. I will answer some reminds while you're doing that. Alrighty, let's take a look at how we did. This one right here, this is even, and it's positive. This one is odd, and it's negative. Oh wow, even Remind is going crazy today. This is great. This one is even and negative because both arrows are pointing down. This one is odd and negative, since it's pointing up to the left and down to the right. Over here we've got another odd function, but this one is positive. This one is odd and negative. No, that's ood, sorry, odd. This one is even and positive. And finally, this one here is also even and positive. Okay, there we go. That's all you need to do. Now, if we're talking about looking at the equation, well, use the same thing. There's a right side and a left side. Okay, this one is even, and the leading coefficient is a positive 1. So it's a positive even. If we come back up, positive even, there it is. Here's some other positive even ones right there. So the right side goes up, and the left side goes up. Okay. This one here is odd. That is negative. An odd one, the right side goes down, and the left side goes up. Okay. And then this one right here, that's an even number, that's 4. And that's an odd number, a negative 1. So the right side is going to go down, and the left side is going to go down. All right, guys. If there's any questions at the moment, please feel free to type them in. Obviously, I can't hear what you're saying, but I definitely want to help if I need to. Yeah. Thought the last one would go up. Well, no, because right here that is a negative, and it's even. So negative even, that's this one right here. They both go down. Okay. Same thing over here. If I were to, and here's what I would probably do if I were taking a test right off the bat: positive, negative, even, odd, sketch, 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 sketch. Okay? That's what you're going to go off of every single time. This right here is negative. The 7 is odd. Negative, odd. Right, down, left, up. Yeah, if you were to think about what even basically is telling you is that both the left and right arrows are going to go in the same direction, whatever that direction happens to be. Okay, if they're odd, if the degree is odd, then that's telling you that the arrows, the left and right side, are going to go in opposite directions. Again, what directions those happen to be is determined by whether or not it's positive or negative. This one's positive and odd. Positive, odd, it's right there. So the right side's going up and the left side's going down. Okay. Right here, this is negative, and that 4 is even. We look over here to negative, even. So the right side goes down, and the left side goes down. Alrighty, and then these last two here, and I'm just going to abbreviate right and left. This is even and positive, so right is up, left is up, and this one is also even positive, so right, up, left, up. Okay. Now that's everything you have to know for in behavior. Now the added bit here, and as you can see how I wrote this, because this is math, and everything has to look harder than it really is. There's a certain way that somebody at some point, I wasn't at that meeting 1,000 years ago, that you're supposed to notate in behavior. So take a look at this coordinate plane. If we were to go up forever, and ever and ever and ever and ever, not 2, 4, 6, 8, all the way up to infinity. Alrighty. Down, since we're going down, that's the negative direction. If you go down forever and ever and ever and ever and ever, it's negative infinity. Okay, this is your y value, and I'm going to put something else here in a second, but let's take a look at this. These are your x values. The right side, that's positive. That's also infinity. So the left side, the negative side, is negative infinity. Okay, guys? Now, function notation. Look at all these. N of x, j of x, m of x, p of x, t of x. All of these things are synonymous with y. So the other thing we're going to talk about is, instead of saying y most of the time, we're going to say f of x there. Okay? All that's doing is changing how you're going to say it. It's not changing anything that we already talked about. So when it says right side goes up, okay, the right side, that's the x being infinity. So we're going to say x, little arrow, infinity. That says x approaches infinity. And then we look at up. Up is your f of x, and that's infinity. So we'll say f of x approaches infinity. Okay? Not really doing anything different, it's just notating it differently. And you can look at this chart at any time to help you out with that. You can just sketch it at any moment. The right side goes down. We're still talking about the x, and we're still talking about it being infinity. Here's x, left, right, and there's the right side, infinity. But this time it's going down. So the f of x is going down, which is negative infinity. So we'll say f of x approaches negative infinity. Okay, and then the other two ways to look at it. Left side goes up. That's x approaching negative infinity. Here it is here again. X, left, negative infinity. And up is still f of x going to infinity. And then left side goes down. X goes to negative infinity, and f of x goes to negative infinity. And that is everything that I can possibly tell you about end behavior. Okay, that's the, you can call it the first thing that you look at if you're going to try and graph a polynomial function. And honestly, it may not be the first thing, it's just, you know, one of the few things you have to look at. So how are we doing at the moment? I just wanted to check in really quick. Because now we're going to start talking about roots again. No, we're good. Okay. Guys, this right here, we've been doing this. That's what we spent all last week doing. Okay. First thing we'll do is by finding one of the rational, I don't know why I made that blank so tiny, roots that this function has. So we'll go with 1, 3, 3, 1. We've only got two choices here. We can try positive 1 or negative 1. If we try positive 1, let's see, bring down that 1. 1 times 1 is 1. Add, multiply, add, multiply, add. Definitely not. That did not work at all. Okay, so we'll do negative 1 now. Bring it down, multiply, add, multiply, add, multiply, add. Okay. At this point, there's exactly two roots that are still unknown. This is a third degree polynomial, so there's supposed to be three roots. We found one of them, it's negative 1. From here we can continue completing the square or quadratic formula, or if they do happen to be rational numbers, we can just continue with synthetic division. Okay? However you want to do it. You can do x squared plus 2x plus 1 equals 0. If we were to do the quadratic formula, that's going to be b squared minus 4ac, and that ends up giving you 0. So it is going to be a rational number. Okay, if we want to do it that way, or if you just are a huge fan of continuing with synthetic division, we can do that. Negative 1. This is part of why we have to use the depressed polynomials here. Negative 1 is going to work again. And it's going to work again. Okay, the root, or 0, negative 1, has a multiplicity of 3. And the multiplicity is an odd number. That's something we're gonna deal with a little bit later. Okay, but we need to always know what the multiplicity is for any of the roots or zeros that we find. Okay, let's see how much we can get done here in like the next 10 minutes or so. Find the roots for this function. Now, you might have remembered me saying before, we might have still been in class when we did this one, but placeholders. Degree of 4, 3, 2, 1. What we're missing is the constant. So we need a placeholder at the end. Now, if the placeholder is at the end, go ahead and just do 0 first. So we know that 0 is going to be one of our 4 zeros. Okay, we just need to remember that one of the 4 roots happens to be 0. Okay, at this point we can use the rational root theorem to continue with this here. We've got 2, which would either be a 1 or a 2, and a 1, which is 1. I don't know which one's going to work, honestly, so let's just go ahead and start with 1. How about 1? My recommendation is always, always, always to start with either 1 or -1. More often than not, one of those is going to work, and 1 is not one of the ones that's going to work. Now, here's the thing. We've already used 1. That means no matter what we do, even when we find one of the roots, 1 is still not going to work. And that will be useful to us. Okay, we found one of the other roots. It's -1. Now, there's no point in trying 1 again. We already know it doesn't work, but it might be useful to go ahead and try -1 again. Okay, -1 times 1, that's -1, plus 3 is 2, times -1 is -2, and there you go. Since we've got it down to 2 numbers, you can either think of this as x plus 2 and solve that, set it equal to 0, or continue with synthetic division, we're going to do -2. So these are the other 3 zeros that we've got. How to what exactly? Which item are we looking at? All right, I'll keep on sliding down until I see the rest of your question post up. So the roots, we have 0, which had a multiplicity of 1, which is an odd number. Then we found -1. Now it happened twice. So -1 has a multiplicity 2. And 2, last I checked, was an even number. And then finally we found the number, what was it, -2? Yeah, -2. It worked 1 time, so multiplicity of 1, which is an odd multiplicity. Okay, here we go. Let's see what all that significance is when it comes to multiplicity. A root's multiplicity is going to tell you exactly what the graph does at that x-intercept. If the multiplicity of the root is odd, it's going to go through the x-axis. Meaning it's just going to pass right through. Like here's your x-axis, here's your root, and boom, went right through it. If it is even, it will bounce. Sometimes it's called touch. In other words, here's your coordinate plane again. Here's that same 0. It would doop, and then come back like that, like the vertex of a parabola, essentially. That is basically everything you need to know in order to graph a polynomial. The only thing we haven't talked about is Y-intercept. We'll hit that when we get to it. But here we go. Step 1, draw arrows in the appropriate quadrants to indicate in behavior. This is even and it's positive, so we know that the arrows are going to both be pointing up. Okay. The next step is to plot all of the zeros or roots. This is the one that we just were doing here. So we have 0, we have -1, and we have -2. Let me zoom in on this like a whole bunch here. Okay. Now this one has an odd multiplicity. I'm just going to put a little O there. This one had an odd multiplicity. I'm going to put a little O there. And I'm going to put a little E for this one. It had an even multiplicity. Okay. You don't have to do that. It's just a nice little reminder. We're basically done. Just draw it. Okay. Here we go. Starting at this, you can start at either arrow. It doesn't matter. So starting here, and we get to this one. Oh, odd. That means it's going to go through the x-axis. Okay, boom. Now we went through it. And this part doesn't really matter too much to me when we're doing it in our class, but you're just going to have to turn it around. Exactly where you turn it around, not super important for the context of what we're doing, but now it comes up to the next 0, the next root, the next x-intercept, and it is an even multiplicity. Even multiplicity means instead of passing through, okay, this axis is now acting like a wall and it's going to bounce away from it. Once again, doesn't really matter where you turn around, but you got to turn around. And we hit this final 0. It's an odd multiplicity. Odd means you're just going to go right on through. And there we go. Now that looks, I will be honest, absolutely terrible from a accuracy standpoint, but it has all the features that I'm looking for from you guys. Okay, the arrows are both pointing up. It's even. We've got zeros at -2, -1, and 0. This one has an even multiplicity, so it was a touch or a bounce. Both of these are odd multiplicities, so they are both throughs. And if we do it correctly, everything lines up perfectly. Meaning, we started at this arrow, and if we just follow the directions of whether we're supposed to go through or we're supposed to bounce, you'll end up where the other arrow is as well. And I kind of ignored all those steps here, but you get the idea. So here we go. Follow the same 4 steps to sketch this guy. Okay. Now this one we've actually already done. If we scroll back up to... here it is. Okay. X to the third plus 3x squared plus 3x plus 1. For this one, we found that -1 had a multiplicity of 3. Okay, so coming all the way back down, the root is -1 with with a multiplicity 3. Okay. So here is -1 with a multiplicity of 3. Something I haven't addressed yet, and that's the Y-intercept. And I don't want to spend a whole heck of a lot of time on this one because, oh good, Schoology's back up it sounds like. Why I said that out loud I don't know. The constant. The constant term is your Y-intercept. Go ahead and plot that too. The last one we just did, there was no constant term. In other words, it would be plus 0. And it did touch the y-axis at 0. It just also happened to be one of our x-intercepts. This time it's different. It is going to be 1. Now this is positive, which means we're going to put an arrow down here and an arrow up here. Now if we did this right, doesn't matter which arrow you start at, we should be able to go through both those dots and follow the directions. This is odd, which means it is a through. I don't know why I put a P there. Here we go. So going up, little curve there, and boom. We've hit this one. It is an odd multiplicity, so I'm just going to keep going. We went through the y-intercept, and there we go. We hit the other arrow. That's it. We have graphed another polynomial function. How much did we have left to do here? Okay, guys, it looks like the only things left are some examples that I put up rather than spending any more time on the live stream here because it's been about 42 minutes and I don't want to go much longer than that. I am scheduled to do a conference in Schoology. Hopefully it'll be up and running, but I can look at these examples with you guys then. So if there's no other questions at the moment, I can go ahead and sign off. All right, guys, I will catch you later. Be sure to contact me if you've got any questions as you're working through the assignments.